5.6, happy Halloween! For those of you who don't know, 5.6, we already covered 5.6a. The things that you need to know, first and foremost, are that the formulas we are going to use are in the 4.1a notes. So if you have forgotten what the 4.1a notes are, good thing I'm organized and I have the 4.1a notes right here. And what you will see are three formulas: a midpoint formula, a slope formula, and a distance formula. The good thing for you is I have those memorized, so I don't need to look at them, but maybe you do. So you might want to look back at that because it's going to be handy while you are doing this worksheet. We'll write them down, as a matter of fact. If two things are parallel, then their slopes are going to be the same. So if I want to know if one side is parallel to another side, I have to find the slope of this side and find the slope of this side and see if those two slopes are the same. If the slopes are the same, they're parallel. That'll be an easy way to tell if something is parallel or not. Something we haven't talked about since Math 1 are that what happens if the slopes are perpendicular. If they're perpendicular, they are opposite reciprocals of each other, meaning one's a positive and one's a negative, and they're reciprocals or reflipricals. If one slope is 3/2, then the other slope would be negative 2/3. One's a positive, one's a negative, and they're flipped from each other. If you saw a slope that was like this, let's say of AB, and you saw a slope of, let's say, BC was like this, then what you would know, since the slopes are opposite reciprocals, that AB is perpendicular to BC if you saw that. Lastly, distance formulas are always positive distances. Don't ever find, if you find a distance that's negative, then you're not doing it correctly. Keep that in mind. So, with all that being said, this is that first big box that you have on your worksheet. This should be the same exact thing that you see there. And I thought, man, if they understand this big, gigantic box, they're going to do just fine on this test coming up next week. But there might be some things in here that you need some help on, so we'll do this together. First and foremost, the slope formula, if it's the same slope, they're parallel, that's A. The slope formula, if the slopes are opposite reciprocals, then they are perpendicular. They're just telling you, you're going to choose A when this happens, you're going to choose B when this happens, but we should probably write down what the slope formula is. If you don't know it, this is what I would have you write down on your worksheet. The change in y, y2 minus y1, over x2 minus x1. That's your slope formula. Let's just put it right underneath there on that worksheet. That will start us off. Then they ask us, they tell us that we're going to use the letter C for the same midpoint, which means they bisect each other. But we should know what the midpoint formula is. The midpoint formula is the average between your x's. How do you find the average? You add them up and divide by 2. And you find the average of your y's. How do you find the average? You add them up and divide by 2. The average of your x's and the average of your y's is the midpoint formula. That's how you find the exact middle point. The distance formula is the Pythagorean theorem. It's the square root of the difference of your x's squared in parentheses plus the difference of your y's squared. It's like the Pythagorean theorem. So just in case we need them, I tried to put down what the three formulas are for you. And then what we're going to do here is we're going to fill in this chart together. It says, in each blank, write either A, B, C, or D, stating which formula should be used to verify the property. If we have a parallelogram has opposite sides parallel. Would I use the distance formula for that? No. Would I use the midpoint formula for that? No. Would I use the slope formula because I'm talking about parallel? Yes. Now, am I going to use A, same slope, or am I going to use B, opposite reciprocals for perpendicular? I'm going to use A. That's what goes right there. Pretty simple. The second thing for a parallelogram, if the opposite sides are congruent, then it's a parallelogram. If the opposite sides are congruent, the same size and the same shape, the same length, am I going to use slope, midpoint, or distance? What do you think? If you think you know the letter, go ahead and say the letter out loud and we'll see how many people say it correct. Go for it. I agree. I heard a lot of people say D. Good job. You are right. If the diagonals bisect each other, then it's a parallelogram. So how would I check to see if the diagonals bisect each other? We need to use their midpoints. So which formula for that? If they have the same midpoint, then they bisect each other. That's letter C. Let's go a little bit faster. If one pair of opposite sides are congruent and parallel, well, we're going to need to use two formulas for that. How do we find if they're congruent? They have the same distance. So I know that's D. And how do we figure out if they're parallel? We're going to use A, the same slope. So this is A and D. We have to use both of them. And so the whole idea behind this is we need to know which formula to use to be able to use this property to be able to name the object. You're going to be doing problems like this where you're given something and you have to decide what it is. And if you're going to tell me, oh, I know that is a rectangle, then you're going to have to prove it. You're going to have to show me properties of rectangles. And this is trying to lead you down the road that you go, okay, if I want to prove that they're parallel, I can use A. Or if I want to know if the midpoints are the same, then they bisect each other, then I can use the midpoint formula, and so on. All right, a rhombus, all sides congruent. That has everything to do with distance. So distance would be D. If the diagonals are perpendicular, there's only one letter here that deals with perpendicular. If you know that letter, say that letter out loud. I agree. Rectangle, adjacent sides perpendicular. So there's only one other thing that we have to do that deals with perpendicular. What letter is that? For those of you who said B, there are 3 of you I heard. Perfect, you have it correct. If the diagonals are congruent, then it would be a rectangle. And the diagonals being congruent, you have to know their lengths are the same. Which formula would we use? I agree. A square is a property from a rhombus and a rectangle. They both have to be the same. Trapezoid, one pair of opposite sides are parallel, not both. What's formula? A. Isosceles trapezoid, a trapezoid with legs congruent. How do we figure out how they're congruent? We have to know that their distances are the same. D. And diagonals congruent. We're going to use D as well. What I like about this worksheet, even though we had to go and do formulas and figure out which formulas, it also basically summarizes. If you want to know if it's a parallelogram, these 4 things have to be true. And if one of them's true, then that's a parallelogram. If that's true, then that's a parallelogram. If that's true, then it's a rhombus. If that's true, then it's a rhombus. You can figure out this summarizes each of our 1, 2, 3, 4, 5, 6 different shapes you need to know. For example, I'm only going to do number 4 with you, and then I'm going to give you time to work on this by yourself. Number 4 says, what's the best classification? And you're going to look at this shape and you're going to make a decision. You're going to say, is it an isosceles trapezoid, a trapezoid, a square, a rectangle, a rhombus, or a parallelogram? And you have to decide. Let's say you're not sure. Let's say you've narrowed it down. You go, I wonder if it's a rectangle. I wonder if it's a parallelogram. What you should be thinking is I need to know what this angle is. I need to know that angle that Mr. Paramo has highlighted. Is it 90 degrees or is it not 90 degrees? Because that's going to make the difference. If that's 90 degrees, then I have right angles, and because it has right angles, it might be a rectangle. So how do we check? You're going to use these points. This is 1, 2, 3, 4, 5, 6. Sometimes I do this, just makes my life easier. 2, 3, 4, 5, 6, 7, 8. I start numbering my axes. Let me zoom in on that just a little bit. And then what I do is I go, okay, well, this point is 3, x first, horizontal first, then vertical second. I find this point, these vertices, 6, 4, because x, then y. It goes in alphabetical order. This is 4, 8, because we do the x, then the y. And then for this corner, we do the x, then the y, the 1, 6. So now I have my 4 points. If I want to know if that's a right angle, which is my question, is it a right angle? I'm not sure. I need to find the slope, and I'm going to just highlight this here in 2 different colors. I have a blue, and then I'm going to go back and highlight in yellow. I need to know what the slope of the blue line is and what the slope of the yellow line is. So how do I do that? I'm going to find the slope of the blue by doing, this says M, B-L-U-E, blue. The slope of the blue one is going to be y2 minus y1, 6 minus 2. y2 is the y value. This is your other y value. 6 minus 2 divided by x minus x, 1 minus 3. If you do 6 first minus 2, then you have to do 1 minus 3. You have to subtract in the same direction, which makes this 4 over negative 2, which is negative 2. It goes down 2 over 1, down 2 over 1, which makes sense. Now I'm going to do the slope of the yellow. And the slope of the yellow, y2 minus y1, y2 minus y1 over x2 minus x1. And when you look at these, what I'm checking to see is, are they opposite signs? One's a negative, one's a positive. Yes. Are they reciprocals of each other? This is negative 2 over 1. This is 2 over 3. Are they perpendicular? Are these opposite reciprocals? No. This is not a 90-degree angle because the slopes do not make opposite reciprocals. Which means this cannot be a rectangle. This cannot be a rectangle. And if I look at these and I start checking the slopes of this one, let's just do the rise over the run. Rise of 2, run of 3. This slope is a slope of 2/3. Let's check this other slope over here. It's down 2 over 1, down 2 over 1. This slope is negative 2. So I know the opposite sides are parallel and the opposite sides are parallel. What does that make this shape? What's the best name for this shape? I bet you know. If you said parallelogram, you are correct. That's the decisions that you're going to have to make. What I do not want is I do not want you just to write down that it's a parallelogram. I want to see you use the formula at least once or twice to figure out which is the best classification. If you think it's a rhombus, then I better see a distance and a distance formula. And so on. I hope that makes sense to you. If you think it's a rectangle, I better see that these are congruent and these are congruent as well. And there better be a right angle symbol there. Okay? So I'm going to stop your notes right there.